Chapter 2, Section 4 is on biconditional statements and definitions. By the end of this lesson, you should be able to write and analyze biconditional statements. So what is a biconditional statement? When you combine a conditional statement and its converse, you create a biconditional statement. This is a statement that can be written in the form P if and only if Q. That means if P then Q and if Q then P are true. So we use a double arrow here showing that it can go either way, P then Q or Q then P. So here's an example of one. So conditional statement. If the sides of a triangle are congruent, then the angles are congruent. Here's our P, here's our Q. The converse of that statement would be, when we switch it around, if the angles of a triangle are congruent, then the sides are congruent. And a biconditional combines them. We tend to write the P first just because that's what we normally do. The sides of a triangle are congruent if and only if the angles are congruent. So that if and only if lets us know that we've combined a conditional and a converse to get that biconditional statement. Write the conditional statement and its converse within each biconditional statement. So the first one, an angle is obtuse if and only if its measure is greater than 90 degrees and less than 180. So the first thing we have to do is identify what our P is and what our Q is. So this right here, an angle is obtuse, we're going to let that be our P. And then its measure is greater than 90 degrees and less than 180. That's going to be our Q. So our conditional statement, what we start with, says if an angle is obtuse, then its measure is greater than 90 and less than 180. And then the converse of this, remember, is when we just switch P and Q around. So we have now if Q, so if an angle measures greater than 90 and less than 180, then it is obtuse. So same thing with the next one. A solution is neutral if and only if its pH is 7. So remember that double arrow right there means if and only if. So again, identify your P, identify your Q. This is our P, if and only if our Q is true. So our first conditional statement says if a solution is neutral, then its pH is 7. Where the converse of this would be the other way around. If a solution's pH is 7, then it is neutral. So in addition to being able to pick apart a biconditional statement, we should be able to write a biconditional statement. So the first thing you have to do is write the converse, because then you need to combine them once you put them, or once you write them both out. So if 5x minus 8 equals 37, then x equals 9. The converse of this would have our P and our Q switched around. So here's our P, then Q. So now we're going to say if x equals 9, then 5x minus 8 equals 37. So the biconditional statement combines those two. and says 5x minus 8 equals 37 if and only if x equals 9. Same kind of thing for the next one. If two angles have the same measure, then they are congruent. So the first thing we have to do is figure out the converse of this. Switch around our P and our Q. So if two angles are congruent, then they have the same measure. So the biconditional statement, remember, takes out the if-then and replaces it with if and only if. So two angles have the same measure if and only if they are congruent. So truth value, hopefully you noticed that, especially this one back here, wasn't necessarily a true biconditional statement. So for a biconditional statement to be true, both the conditional statement and its converse must be true. If either the conditional or the converse is false, then the whole biconditional statement is also false. So determine if each statement is true. If false, give a counterexample. So a rectangle has side lengths of 12 centimeters and 25 centimeters, if and only if its area is 300 centimeters. So we have two things here. We have our P and we have our Q. So is it true, front ways, if P then Q, if a rectangle has side lengths of 12 by 25, 12 by 25 is the only possibility for area 300. If we do some quick math, yes, that one works. Then the other way around, if Q, then P. So if we have an area of 300, are there ways to get to it besides 12 and 25? Well, yeah, we could have something like 10 by 30, and that would also give us 300. So the converse is false. So even though the conditional statement is true, the converse is false. So that means this biconditional statement is false. And here's our counterexample. Let's do another one. Determine if each biconditional statement is true. If false, give a counterexample. So a natural number n, remember natural numbers are counting numbers like 1, 2, 3, 4, 5, is odd if and only if n squared is odd. So figure out your P and figure out your Q and then see if it works both ways. So if a natural number is odd, n squared is odd. Let's do some examples. So if we have 1 squared, we get 1. 3 squared, we get 9. Next one would be 5 squared, we get 25. 7 squared, we get 49. We can keep going all day, but anytime you square a natural number that's odd, you're going to get an odd number out. So now let's do the other way around. If Q, then P. So n squared has to be a natural number. So we're kind of just going backwards from what we just did. The square root of 1 is 1. That's odd. Square root of 9 is 3. That's odd. Square root of 25 is 5. That's odd. And again, we could keep on going. So there's no counterexample that can prove this false. So this is true. So in geometry, biconditional statements are used to write definitions. A definition is a statement that describes a mathematical object and can be written as a biconditional. So write each definition as a biconditional statement. So here's a definition for a pentagon. It's a 5-sided polygon. So we can turn this into a biconditional statement by putting an if and only if in there. So a shape is a pentagon if and only if it is a five-sided polygon. Next one, a right angle measures 90 degrees. That's a definition. So we can say an angle is a right angle if and only if it measures 90 degrees. So, end of the lesson. You should be able to write and analyze biconditional statements. And remember, we'll do lots of practice with this on Monday. Enjoy your weekend.